Euclid telescope dazzles with detailed first images of our universe. The European Space Agency's premier telescope captured new views of space, a small taste of what it is likely to accomplish in the coming years. Whether capturing spiral galaxies or stellar nurseries, Euclid is showing off our universe's good side. On Tuesday, the European Space Agency shared the first images from the robotic telescope in space, 5 ethereal views of our cosmos. Launched in July, Euclid is on a quest to map a third of the extragalactic sky and to reveal how the mysterious influences of dark matter and dark energy have shaped the structure of the universe. The new images are just a taste of what scientists expect the space telescope to achieve. "I'm just overwhelmed by the sheer scale of the data," said Michael Seifert, a cosmologist at NASA's Jet Propulsion Laboratory who is a member of the Euclid mission. "The ability to have really sharp images cover a wide field at the same time is just really astounding. Perhaps most striking is a shot of the Horsehead Nebula, a star factory 1,375 light-years from Earth with a distinct equine-shaped cloud. The image shows reddish-brown gas and dust churning with baby stars, young Jupiter-like worlds and rogue planets detached from a host star. In the lower left corner, massive infant stars cast the interstellar clouds of another nebula, NGC 2023, in a soft lavender glow. Scientists also released a spectacular new view of the Perseus cluster, an aggregation of galaxies 240 million light-years away. "Most of the colored specks are not stars, Dr. Seifert said, but galaxies, some so faint they have never before been seen. Free-floating stars, stripped from their galaxies and drifting in the spaces between, may also be nestled in the cluster." The Euclid team also shared close-ups of galaxies. A wispy white spiral, IC 342, similar to our Milky Way, and an irregular dwarf galaxy, NGC 6822, among a dense field of stars. The final image shows the globular cluster NGC 6397, a collection of stars orbiting in the disk of our own galaxy. These are exquisite images over vast areas of the sky taken very quickly, to great depths with razor-sharp precision. Carol Mundell, the European Space Agency's science director, said on a live broadcast on Thursday. "And it's those ingredients pulled together that is going to make Euclid the iconic cosmology mission of the day." Whereas NASA's James Webb Space Telescope zooms in on one part of the sky at a time, Euclid excels at imaging wide, but still detailed, swaths of the universe. "That's perfect for when you want to look for a needle in a haystack," Dr. Seifert said, including objects like free-floating worlds. With the data Euclid sends home, researchers can learn about how the web of dark matter cementing our universe together influences the shapes and motions of visible objects in space. The telescope's detailed resolution is also expected to help scientists map the distribution of galaxies across cosmic time, aiding in understanding dark energy, the inexplicable force pulling the universe apart. The mission team is wrapping up final checks and calibrations of Euclid's instruments, which include a 600-megapixel camera for imaging and a near-infrared spectrometer and photometer that will record the light from galaxies in wavelengths that are not visible to infer their distance. Over the summer, scientists worked around the clock to fix a faulty navigation sensor that made Euclid create images of winding star trails as the telescope tried to capture a piece of sky. Today's cosmic snapshots represent a testament to the perfection of the instruments, the mission and the optics, and how they've all been built and delivered up into space, Dr. Mundell said. Scientific observations are scheduled to begin early next year. In 2025, scientists plan to release Euclid's first maps of the universe, which will include more sky area than in all of the data collected so far by NASA's Hubble Space Telescope, Dr. Seifert said, and the team anticipates that Euclid will chart the sky over the next 6 years, assembling a trove of 12 billion sources for astronomers to dig into and discover. The data that came out represents less than a day's worth of observing, Dr. Seifert said about Euclid's first images. "We are just going to be drowning in data for years and years to come." The dark universe is waiting. What will the Euclid telescope reveal? The European Space Agency mission, which launched on Saturday, will capture billions of galaxies to create a cosmic map spanning space and time. At 11:12 a.m. on Saturday, the Euclid spacecraft launched into space on its mission to chart the history of our universe as far back as 10 billion years ago. The Space Telescope, built by the European Space Agency, will use its instruments to record more than a third of the extragalactic sky over the next 6 years, creating the most accurate three-dimensional map of the cosmos to date. Researchers plan to use Euclid's map to explore how dark matter and dark energy, mysterious stuff that makes up 95% of our universe, have influenced what we see when we look out across space and time. Euclid is coming at a really interesting time in the history of cosmology, said Jason Rhodes, a physicist at NASA's Jet Propulsion Laboratory who leads Euclid's U.S. science team. We are entering a time when Euclid is going to be great at answering questions that are just now emerging. And I am certain that Euclid is going to be fantastic for answering questions we haven't even thought of. The spacecraft lifted off from Cape Canaveral, Fla, on a SpaceX Falcon 9 rocket. The weather was almost perfect for the flight. Euclid, still attached to the rocket's second stage, separated from its booster 3 minutes after launch amid a round of applause. It entered a stable orbit around Earth nearly 9 minutes after the flight. About 40 minutes later, the telescope separated from the second stage and began a journey of 1,000,000 miles to a point in space where the mission's scientific journey would begin. Unbelievable, said Guadalupe Caz Herrera, a theoretical cosmologist on the Euclid mission, when asked about the launch on the ESA video stream. I'm super emotional, but also extremely thankful for everything that has been done so far so that we can actually have a telescope in space. The European astrophysics mission had no choice but to fly American. ESA had planned to launch the spacecraft on either a Russian Soyuz rocket or Europe's new Ariane 6 rocket, but because of a break in the European-Russian space relationship after the invasion of Ukraine and delays for Ariane 6, ESA moved some launches to SpaceX, including Euclid. The spacecraft will not be alone in peering into the cold storage of our universe, but unlike the Hubble and James Webb Space Telescopes, which focus deeply on one part of the sky at a time, scientists will use Euclid to cover wide swaths of the extragalactic sky at once. In 3 of the regions it records, Euclid will reach back even farther, imaging the structure of the universe about 1 billion years after the Big Bang. One of the space telescope's targets is dark matter, the invisible glue of the cosmos that doesn't emit, absorb or reflect light. Dark matter has so far evaded direct detection, despite physicists' best efforts, but they know it exists because of its gravitational influence on the way that galaxies move. Dark energy, on the other hand, is a much more mysterious force that pushes galaxies apart, so much so that our universe is expanding at an accelerating rate. Euclid's maps of the cosmos will reveal how dark matter is distributed across space-time based on how it warps the light from galaxies behind it, an effect known as weak gravitational lensing. That's distinct from strong gravitational lensing, more dramatic warping by galactic clusters that creates arcs, rings, or even multiple images of a single source. These measurements contribute to more direct efforts to figure out what dark matter actually is. We are looking for the same thing from different angles, said Clara Nellist, a particle physicist at CERN in Europe who is not a part of the Euclid mission. Researchers on Earth-based experiments hunt for signs of dark matter particles colliding with their detectors. Any information we gather about how it's distributed in our universe helps us to look for it in our collisions in a more focused way, Dr. Nellist said. With Euclid, scientists hope to be able to test if Albert Einstein's theory of general relativity works differently on cosmological scales. That could be related to the nature of dark energy. Whether it is a constant force in the universe or a dynamic one whose properties vary with time. If we find out this is not a constant, but something that changes in time, then it would be revolutionary, said Xavier Dupont, an ESA cosmologist on the Euclid mission, because it would overturn what is known about fundamental physics. Such a discovery could even shed light on the ultimate fate of what seems to be our ever-expanding universe. Euclid hosts a visible imager consisting of a 600 megapixel camera that can photograph an area as wide as 2 full moons worth of sky at a time. With this instrument, scientists will be able to glean how the shapes of galaxies get distorted by dark matter in front of them. It also has a near-infrared spectrometer and photometer, which will be used to both record galaxies in non-visible wavelengths as well as measure their redshift, the wavelength stretching effect in light arriving from the faraway cosmos that results from the expansion of the universe. When used in conjunction with a suite of ground-based instruments, including the Subaru and Canada-France-Hawaii telescopes at Mauna Kea Observatory and eventually the Vera C. Rubin Observatory in Chile.